A golf ball is driven so that its height in feet after t seconds is given by the function h of t is equal to negative 16t squared plus 48t plus 20. Find the maximum height of the golf ball. Let's first of all use our calculator to explore. Go to y equals to enter the function. For the given function, t is the independent variable, but on a calculator, x is the independent variable, so enter negative 16x squared plus 48x plus 20. Next, let's create a table of values. First of all, we'll go to table set, which is second window. To find the initial height of the golf ball, we'll let t equal 0, so table start is equal to 0. We only expect the golf ball to be in the air for a few seconds, so we'll increment by 1 second at a time. Make sure that the independent and dependent variable are on auto so that the table automatically fills in for you. Then go to table, which is second graph. Now in the table, notice that we have some symmetry. The y value is 20 at both 0 and 3. The y value is 52 at both 1 and 2. Therefore, the axis of symmetry is going to be halfway between 0 and 3, or halfway between 1 and 2, which is at 1 and a half. So, to make our table more meaningful, we might change our increment to half of a second. Let's go back to table set, second window. We'll still start at time is equal to 0, but this time we'll increment by 0.5. Go back to the table, which is second graph. Now we can see the picture more clearly. Initially, the height of the golf ball is 20 feet, and after 1.5 seconds, the golf ball reaches its maximum height of 56 feet. To see a visual representation, we can sketch a graph of the function. We've already entered the equation into y equals, so all we need to do is to go to Window to create a good viewing window. The x values in our table range from 0 to 3 with an increment of 0.5. So we'll enter 0 for x minimum, 3 for x maximum, and 0.5 for x scale. The corresponding y values range from 20 to 56. So we'll enter y minimum is 20. I'm going to choose a value a little bit bigger than 56, like 60. And a scale of 5. Then go to the graph. We see that the graph of the quadratic function is a parabola, and it reaches its highest point at the vertex. To find the vertex graphically, we can use calculate maximum. Go to second trace, select maximum, which is number 4. Use the left arrow key to move to the left of the highest point. Press enter. Then use the right arrow key to move to the right of the highest point. Press enter again. Use the cursor to move as close to the highest point as possible. Press enter. And the calculator approximates the maximum occurring at about 1.5, and the corresponding y value is 56. So again, we see graphically that the maximum height of the golf ball is 56 feet. Finally, to verify this symbolically, we recall that the vertex of a parabola occurs when the independent variable is equal to minus b over 2a. When we're given a quadratic function that has the form f of x is equal to ax squared plus bx plus c, the vertex occurs at the point minus b over 2a, f of minus b over 2a. In this case, we have h of t is equal to negative 16t squared plus 48t plus 20. We can see that the value of a is negative 16. The value of b is 48, and the value of c is 20. So to find the first coordinate of the vertex, we'll substitute 48 for B and negative 16 for A. We get negative 48 over 2 times negative 16. That's 48 over 32, which reduces to 3 over 2. And as a decimal, 3 over 2 is 1.5. So after 1.5 seconds, the golf ball reaches its maximum height. To find the maximum height, we simply substitute 1.5 into the height function. We get negative 16 times the square of 1.5 plus 48 times 1.5 plus 20. We then use a calculator to evaluate this expression. We get 56, so the maximum height of the golf ball is 56 feet. Therefore, the correct answer is C.